In this video, we will discuss the dynamic programming approach to solve computational problems. The dynamic programming is an algorithm design method that can be used when the solution to a problem can be viewed as a result of sequence of decisions. In dynamic programming, in order to solve the given problem, a series of subproblems are solved. The dynamic programming approach is typically used for optimization problems. Let us look at an example. If P is a given problem, then problem P is partitioned into subproblems, and these subproblems may be partitioned into sub-subproblems as well as sub-sub-subproblems, and so on. Let us consider 0-1 knapsack problem. The solution can be viewed as a result of sequence of decisions. Let us consider we have three objects. First, we make decision on object 1 whether to include in the knapsack or not, then on object 2 and then on object 3, and an optimal sequence of decisions maximizes the profit. So, to generalize, in dynamic programming, we have a problem P. It is partitioned into subproblems and sub-subproblems, and the solution to the problem can be viewed as a result of sequence of decisions. In the dynamic programming approach, the subproblems may not be independent subproblems. That is, the subproblem may be overlapping. For example, the sub-subproblem P2 may be combination of subproblem P2 and subproblem P3. In the same way, sub-sub-subproblem P3 may be a combination of sub-subproblem P3 and another sub-subproblem. Therefore, the solutions to the subproblems may also be overlapping. Now, to solve a problem using dynamic programming, the sequence of decisions may be from problem P to subproblem P2, then to sub-subproblem P2, and then to sub-sub-subproblem P2, or the sequence of decisions may be from problem P to subproblem P3, then to sub-subproblem P2, and then to sub-sub-subproblem P2. Now, each subproblem is solved only once, and the result of the intermediate solution is saved in a table. This prevents unnecessary duplicate computations to obtain intermediate solutions. The series of subproblems is planned in such a way that the solution for each subproblem is obtained by combining the solutions to one or more subproblems that are already solved. The optimal sequence of decisions can be found by making decisions one at a time and never make an erroneous decision. One way to solve problems using dynamic programming approach is to try all possible decision sequences and then pick out the best solution. But trying all possible decisions leads to performance issues such as time and space complexities. Dynamic programming approach takes advantage of the intermediate solution of subproblems that are saved in a table which can be used later, thus preventing unnecessary duplicate computation and often drastically reducing the amount of computation of some decision sequence that cannot be optimal. In dynamic programming, an optimal sequence of decisions is obtained by using the principle of optimality. The principle of optimality states that an optimal sequence of decisions has the property that whatever the initial state and decisions are, the remaining decisions must constitute an optimal decision sequence with regard to the state resulting from the first decision. In simple way, the principle of optimality means that in an optimal sequence of decisions, each subsequence must also be optimal. The optimal solution to a problem is a combination of optimal solutions to its subproblems. No matter what the first decision is, the remaining decisions must be optimal. Therefore, the problems using dynamic programming is usually solved iteratively. The word programming used in dynamic programming does not refer to coding or implementation of the algorithm using a high-level language. The term programming refers to the way intermediate solutions are stored in the table for later use. The dynamic programming approach uses a bottom-up approach, where we start with the smallest subproblems and solve them, then combine their solutions to obtain solutions for larger size subproblems until we find the solution to the original problem. So, to summarize the dynamic programming strategy, the dynamic programming is a method that can be used when the solution to a problem can be viewed as a result of sequence of decisions. Dynamic programming approach is used for optimization problems and uses bottom-up approach. In dynamic programming, many decision sequences may be generated. Hence, dynamic programming algorithms often have a polynomial time complexity. Now, some of the problems that can be solved using dynamic programming strategy are multi-stage graphs, all pairs shortest path, also known as Floyd-Warshall's algorithm, single source shortest path, also known as Bellman-Ford algorithm, optimal binary search trees, 0-1 knapsack problem, reliability design problem, and the traveling salesman's problem.